Hello everyone, this is Shweta Patil from Department of E&TC, AISSMS, Institute of Information Technology, Pune. Today we will discuss the LRU page replacement algorithm. The least recently used, that is LRU, it replaces the page in the memory that has not been used for the longest period of time, that is the longest backward distant on the uses. This algorithm, it goes well with the principle of locality. A page that has not been used for a long time is least likely to be referred in the next future or the near future. This algorithm can be implemented by maintaining the backward distance of each page. Whenever a page is referred, its backward distance is set to 0. Backward distance of other page is incremented by 1. So, working on the LRU algorithm can be understood with the help of the following problem. We have a system with 3 page frames for storing the process pages in the main memory. It uses the LRU page replacement policies. We assume that all the page frames are initially empty. We have to find the total number of page faults that will occur while processing the page. The reference is given below, that is 4761761272, and we have to calculate the hit ratio. So with the above given problem, we will find a solution to it. We will draw the main memory with the reference which is given. Let me note down the reference first. 4761761272. This is the given reference. Let me draw the main memory. This main memory is divided into 3 parts. So there will be 3 frames and then the total number of the reference string. As we have already discussed, we are going to use the least recently used page replacement policy. The main memory is initially empty. Hence, 4 will occupy in the first frame. Next, the next sequence is 7. Page 4 will remain as it is. 2 frames are still empty. Page number 7 will occupy the second frame. Next sequence is 6. So 4 remains as it is. 7 remains as it is. And the third frame is occupied the page number 6. Next reference is 1. Now all the frames here are filled. We need to replace one page from this page. For this, the least recently used page is checked. So here 4 is the least recently used page. This 4 will be replaced by 1. So next sequence will be 1, 7 and 6. Next reference string is 7. 7 is already existing in the frames. So the sequence will be 1, 7, 6. Next reference string is 6. 6 also is already existing. So it will be 1, 7, 6. Next sequence is 1 again. 1 also is existing. So here it will be 1, 7 and 6. After that we have the page number 2. Now page number 2 is not present in these frames. Page number 2 needs to be replaced by some of the page from these 3. Now which page we will consider? So 7 was the least used page. That is the distance we can calculate. So 1, 7 will be replaced by 2 and then we have 6. Next string is 7. So from this frames, the least used is page number 6. Page number 6 will be replaced by 7. 2 and 1 remain as it is. After that, the string is 2. 2 is already existing. So we will copy the same sequence, that is 1, 2 and 7. Now calculate the number of hits. We can see that here there is a hit. Here also there is a hit. Here also there is a hit. The page or the page numbers which are not changed, the frame remains as it is. The sequence remains as it is, that is a hit. Here also we have a hit. And elsewhere the pages are in faults. So wherever there is a hit, we will write as H, and wherever there is fault, we will write as F. We need to calculate the hit, number of hit. So number of hit with the help of the least recently used algorithm is 1, 2, 3 and 4. We have 4 hits here, and the number of faults, that is F, it is equal to 1, 2, 3, 4, 5 and 6. There are 6 faults and 4 hits, and we have to calculate the hit ratio also. Hit ratio is given by the total number of page which are hit. So this is the hit ratio. So total number of pages which are hit are 4 by the total number of references. These are the 10 references. So here it will be 10. So hit ratio is going to be equal to 0.4, or we can call it as an 40%. So this was the page replacement algorithm, LRU. Thank you everyone.